Okay, so we're diving into the absolutely beautiful, chaotic world of fractals. And get this, a brand new research paper claims to have cracked a code that a lot of people thought was, well, unbreakable. They found hidden, universal rules that actually connect whole families of these infinitely complex patterns. Let's see how on earth they did it.
It's a great question, right? It almost sounds like a paradox. I mean, fractals are famous for their infinite detail and what seems like total unpredictable complexity. So, how could something that's truly infinite and chaotic actually follow a set of predictable rules? That's really the core question this research set out to answer.
And believe it or not, the answer is a resounding yes. What researchers found is that underneath all that chaos, there's this stunningly consistent and universal structure that governs these different fractal families. Turns out they're not nearly as random as they look. The real question is, how did they find order in infinity?
To get our heads around this, we're going to follow the 5 key steps they took. First up, this idea of a fractal family tree. Then, we'll look at the special tools they use to crack the code, and that brings us to the main event, finding those universal rules. From there, we'll uncover the secret of something called the Stokes constant, and finally, we'll see how it all comes together to create a complete fractal atlas.
Right, so before you can find rules in chaos, you've got to organize it first. You have to sort that endless complexity into something you can actually work with. And that's exactly where this idea of a fractal family tree comes in. The system they use is called the bird classification. You can think of it like a sorting hat for fractals. It looks at this core mathematical ingredient called the gate function, which is basically the unique recipe for making the fractal. And based on the properties of that recipe, it puts the whole family into a specific class, like class A, B, or C. It gives scientists a way to start comparing apples to apples. And here's a look at how that sorting actually works. It all boils down to one property in that recipe, a value they call alpha. If alpha is between 0 and 1, you're in class A. If it's exactly 1, you're looking at class B. If it's greater than 1, that's B prime. And then there's a separate case, an exponential one, that gives us class C, the Aether family. All of a sudden, what was chaos now has, well, a map of the different territories. Okay, so we've got our families all neat and organized, but how do you actually look inside them to find the rules? Well, for that, you need a very special mathematical toolkit. Let's open it up. The big picture approach is called the resurgence program. Now, you don't need to be a mathematician to get this. Just think of it as a method for taking super complex, messy math, the kind that describes fractals, and finding these deep, hidden relationships and structures that you just can't see on the surface. And one of the key tools in this whole program is something called the Borel transform. Honestly, the best way to think about it is like a super-powered camera lens. Imagine you have this blurry image made up of an infinite number of little data points. The Borel transform adjusts the focus, cuts right through all that noise, and reveals a single, sharp, and fundamentally important structure that was hiding underneath it all. And this is where it all comes together. By using these incredibly powerful tools to look at the different fractal families they'd organized, the researchers, well, they made a truly stunning discovery. And here's the headline. They found that a universal mathematical structure exists across completely different fractal classes. The fundamental patterns that their analysis revealed weren't unique to each family. They were shared. It was the same underlying blueprint. This really puts into perspective just how big of a deal this is. Before this work, the thinking was that every family, class A, class B, class C, was kind of its own little island with its own set of laws. But this research is like building a bridge between them all, showing that on a deep, structural level, these islands are all part of the same continent, all governed by the same fundamental rules. So how sure are they about this? Well, the numbers are pretty solid. Their tests confirmed these universal properties. They measured these key structural values, they call them gamma exponents, and found they matched across the different families with an error of less than 4%. I mean, that is an incredibly high degree of accuracy. It's powerful evidence that this universal structure is the real deal. But hang on a second. If so much is universal, then why do the fractal families still look so different from each other? What makes a class A fractal, well, a class A fractal and not a class C? The answer lies in one special number that holds the secret to each family's unique identity. And that number is called the Stokes constant. Here's a way to think about it.
The overall blueprint for building a house might be universal, right? But the Stokes constant is like the specific paint color you choose for the front door. It's the one piece of information that is not universal, and it carries the unique DNA that defines the individual character of each fractal class. The paper itself puts it perfectly. It says that this specific formula is what carries the unique class-dependent information. So while the deep structure might be the same everywhere, this one value changes from family to family, and that's what makes all the difference in how they look and behave. So let's put it all together. They found the universal rules, and they figured out the unique identifiers. With all that in hand, the researchers were able to achieve their final goal, creating a comprehensive map for this whole territory of infinite patterns. Now, a discovery like this doesn't just happen overnight. It was built on years of work. You see, researchers had already mapped out the rules for one family, Class C. This new paper was the crucial next step. They extended that analysis to all the other families, Classes A, B, and B'. And when they confirmed that the universal laws held true for all of them, they could finally combine everything into a single, comprehensive guide, which they call a complete Borel atlas. And let's be super clear here, this atlas isn't a coffee table book of pretty fractal pictures. It is so much more powerful than that. It's a theoretical guidebook. It's a set of rules and a predictive map that explains the fundamental mathematical physics behind these incredibly complex systems. Think of it as a map of the laws, not just a map of the land. So what's the big takeaway here? What does this all mean? Well, for one, it proves there's a deep, hidden unity connecting these seemingly random and different types of fractals. It also gives scientists a powerful, predictive framework to understand these kinds of complex systems. But I think most importantly, it's just this profound reminder that even when we're staring at infinite complexity, we can still find elegant, understandable, and universal rules. And that, really, is the most exciting question of all, isn't it? If this much profound order can be found hiding inside the infinite chaos of fractals, what other universal rules are out there just waiting for us to find them, hidden in plain sight in all the complex systems that are all around us?